You ever wonder about the people in family photos, or ever try to ask who these people really were? Every face is a narrow escape or a love story that almost didn't happen. Your family stories are hidden in plain view. You just haven't accessed it yet. There are versions of these rebels and dreamers before life told them who they needed to be. And I'm not talking about the shiny stories everyone knows. I'm talking about the soul-crushing experiences with heartbreaks and real loss. You got to preserve these stories now. So contact the VietnamStoryBank.com today. No polish, just raw, recorded, beautiful history that makes you sit up and hold your breath. We dig it all up, record it, and hand it back to you. Safe, unerased, untouchable, and unforgettable. Don't let silence have the last word. Go to VietnamStoryBank.com today. Make sure your family's stories are recorded. Welcome to the Vietnamese Podcast. Today I have Kevin Quach. You are a Blue Origin aerospace engineer, and you and I met in New York last week. And we were in a club in the back room in an enclave, and we were just talking about this stuff that you do, and I found it so interesting. I always found the Blue Origin and SpaceX rocket companies as these very interesting companies. And the more we talked, I mean, I knew that I'd have to ask you on to the podcast, but the more we talked, the more I wanted to really explore this idea of space travel and the ideas behind the technology. So welcome to the podcast.
Yeah, thanks, Kenneth. It's always good to see you again. New York was a good time.
It's a great time. So let's talk about how early in your life did you have this idea of wanting to become a rocket scientist?
Yeah. So, I would say pretty early on. My growing up as a kid, my dad, he had all sorts of stuff in the living room. Like he had all these books, like encyclopedias with like just pictures of airplanes. Like literally, it's a picture book, except it's just full of jets and all sorts of aircraft. He had models all over the fireplace of little planes on the shelves and things like that. And I would, I'd read through the books because, pictures, right? Picture books. So you kids love them, right? So instead of picture books of like, I don't know, Barney or Winnie the Pooh, I was looking at picture books of like military aircraft and jets and airplanes. And I had that influence pretty young, right? As soon as I could really read on my own. A aerospace engineer or work with rockets specifically. I just had I knew I wanted to build something, right? Make something. I thought I might be an architect, right? When I was in elementary school, I was like, oh, maybe I want to be an architect. I would draw buildings and like, oh, maybe I can design buildings when I get older. And then in middle school, I wasn't quite sure in middle school either yet exactly if it was going to be aerospace or rockets or anything like that. And it really took hold, I think, when I was in high school, and I really started thinking, your brain's a little bit more formed, in high school, and you're like, oh, what do I actually want to do? And from there, I pretty much knew I wanted to do aerospace or some form of engineering. And I just looked back at all my memories and all the things that like I really connected with as a kid. And I was like, I got to do something with planes, or it's got to be something that flies, right? And so coming out of high school, I was pretty dead set. I knew where I wanted to go to school. I knew what I wanted to study, and it just took off from there, really.
Is aerospace engineering one of those fields where it's like a very narrow window, like the medical field, if you want to be a doctor? Is it hard to get in?
Yeah, so I would say, relatively speaking, aerospace engineering is probably a smaller group of folks who are getting degrees in that compared to maybe more general engineering degrees like mechanical type of degrees. Yeah, it's a bit more niche in a sense. I like to think of aerospace engineers like a jack of all trades but master of none type of field, because you have to learn about all the different systems that compose of modern day aircraft or launch vehicles or rockets, right? And so to fully understand the whole system, you have to learn about it all, right? Like rockets and planes are not simple aircraft or inventions, right? They comprise of many small systems. So we have to learn about all of them. So I would say we have a pretty good understanding of what it all takes to put the plane together or the rocket together. But we still, as an aerospace engineer, he only goes so deep, right? It's like the breadth and versus the shallow. So not to detract that I don't know my disciplines, right? But I would say, as an aerospace engineer, you're more focused on how to put all those things together, focusing on a system that is capable of flying. I would say that's more of what aerospace is focused on.
Yeah, it makes sense. So, all right, we're going to get into the wacky side of this conversation first, because I think by talking about the wacky side of this conversation, we're gonna expose how much you know, which is a lot. And when we were sitting in New York, I wasn't trying to test you. I was like, legit, this has always been on my mind, and I know it's on a lot of my friends' mind. And I get sent these like really wacky, Instagram posts, but I just have to go for it because I think it's going to make a lot of sense once the audience hears what I'm about to ask. Okay. Yeah. This thing about the moon landing being a hoax. Can you walk me through this again? I know you did it in New York with me, but walk it through me again, because I think hearing you explain it to me makes so much sense. And I'm going to send this, obviously this interview, this conversation to many of my friends who believe that the lunar moon landing was not real. And it frustrates me. It frustrates my brother when we hear it. But I think the way you explained it to me really makes a lot of sense. So here we go.
Yeah. So I can kind of see why people would question that, right? Because you think, wow, okay, 1969. Technology back then, right? Like we were running cars with carburetors. Digital electronics wasn't big, right? Like we didn't have phones, PCs. Like there was very we're at the advent of really computing at that time, right? So I can understand, and it's an incredible feat, right? To send people into space and onto the moon and come back, right? Like that's an incredible feat. And even today's standards, I would still say that that's pretty remarkable, right? Like today we still have trouble reliably putting vehicles on the moon. I mean, we do it, right? We haven't put a person on the moon recently, but things are landing on the moon, every year. Different countries are putting things on the moon. I mean, the company I work for is trying to put, people back on the moon again this year. So I'd say I can understand the hesitation or the skepticism, right, when it comes to especially if you weren't around during that time, right? But I would say don't underestimate the technology of people decades ago, right? Just because they had they were in a different time of technology doesn't mean they were much less capable, right? And you got to think like, and I won't get too far into the weeds of like other theories, I'll call them theories, right? Like, think about like the pyramids, think about the aqueducts, think about any other great monument that humankind has created, or any other great feat that humankind has made it. Like they've been making these things for centuries, for millennia, right? With different forms of technology. Just because they don't have today's technology doesn't mean they can't accomplish feats of greatness, right? So I would say, if you really read into the people, the math and the science that was involved with going to the moon, these things are all grounded in reality, right? Like the physics behind it. It makes
doable.
Sense.
These things are doable.
Yeah, of course. Yeah, like the things are there's physically the physics hasn't changed, right? Like what it takes to get off the Earth, escape, Earth's sphere of influence, get into orbit, transfer to the moon's orbit, and land and come back. Like the physics don't change, right? The physics have been there forever, right? Like it just took us a while to understand the math and derive all this stuff, and then apply the technology to get us there. And so I think it's perfectly expected to have that skepticism, but at the same time, it's like, we as humans, we as mankind are very capable when we organize teams together and have the right people in the room, and you really focus on what it takes to accomplish that mission, right? Because if you are, I read books about the whole Apollo 11 and the landing, and these were serious teams. I really respect the people that were part of that mission, and I believe every minute of it, right? Of course, there's going to be some forward-facing, public-facing aspect that they always want you to see. You're never going to show your dirty laundry, right? Like of course, documentaries come out after the fact. They tell you all these crazy things about the people behind the scenes, about what really happened as far as like the politics and the angst and the difficulties and the challenges they had. Right? They want to say, hey, yeah, we had a good time. We accomplished the mission. You don't want people. You don't want to show too much of that, where you know the dirty laundry of the engineering, right? But like these were very committed teams, and I just read about all the rehearsal, all the practice, all the different options that they had, and I think a lot of that had to do with the success, even when it looked like it was almost an impossible task, right? Like these guys were planning like a laundry list of different options of how you could do this. There wasn't just an option A, you know, there was an option A, B, C. You ran out of letters in the alphabet, right? You would have to go back around and come up with more options. But
Yeah.
because that's the idea, right? Like because of the technology limitations and other constraints at the time, you had to, you know, like I say with, you know, if you've ever seen his book's title, Gene Kranz's title of the book, right? It's called Failure is Not an Option. And that's literally it, right? Like they had to accomplish this task, and you couldn't accept no, right? You couldn't accept failure. You had to come up, if this happened, how do you get around it, right? And they had a how do you get around it answer for almost everything, every possible situation they could think of, right? And these things did happen, right? They had lots of failures, they had lots of issues, and not everybody knows about it. They think, oh, was it perfect? No, of course not. There's always little things that happen, and any one of those things could have stopped the mission, right? Now today, with today's technology, we can mitigate that way more effectively, right? Like the number of things that could cause the mission to stop, you know, the likelihood of that has certainly dropped, I would say, with today's technology. So even though they were limited at the time and they had a higher chance of failure, they were still able to do it. So, you know, I very much believe that it happened. Of course, you know, asking an aerospace engineer if the lunar landing has happened is like asking of a you know, a baker believes in bread, right? It's like it's just totally it's fundamental to the study and the existence. To accomplish these really highly technical tasks that rely on a series of events that have to occur all right, you know, many times during that process, you have outs, I'll call them. Like you have ways of getting around a situation. Like there are checkpoints, right? And at every checkpoint, you have like a pick your own adventure type of deal. Like based on what's happening, you do this, right? If this is nominal, okay, you pick option A. If something is slightly off, okay, you do option B. If this is slightly off and that is slightly off, and you know it's a Wednesday, you do option C. You know, it's a very long list of all these different things that will enable you to continue the mission and complete, you know, the objectives. Whereas today, now we still have like many critical decision points when it comes to, you know, flying a mission to space, right? But with today's technology, we can leverage a lot of automation, a lot of computing, a lot of rapid decision-making capability is now embedded into computers and algorithms. Whereas in the 70s, yeah, they had some of that, I would say, but they had a lot more people in the loop, humans in the loop, right, making these decisions, and that's subject to human error, subject to human discretion, ego, personalities, you know. Whereas today's technology, a lot of it is more calculated with computers, that computers are making these decisions, right? So I think that's the big difference between then and now, right? Like we can still, well, we can do what they did and they can do what we did, albeit with today's technology, we're just way more efficient with it, right? Like their computers were much heavier, right? They had to have people, you know, to do this, because not everything could be controlled from ground, right? From the control room, from wherever. So, whereas today, you know, a lot of automation can occur. You don't actually have to have people to do a lot of this stuff. Now, I mean, it can help in certain situations because of comms losses and things like that. But I think that's the big paradigm shift is we're not, you know, we're not today. It's like, the difficulty is not necessarily now it's still difficult, but it's not, I wouldn't say it's the primary thing that's holding us up. It's not that we can't go back. It's how can we go back for way less money and bring a lot more stuff with us, right? And do it way more safe than they did it in the Apollo missions, you know?
So two things. I think
before we actually got to the moon, we actually lost a crew, right? Right before?
Yeah, so there was the Apollo 1 fire.
Okay.
Yeah, so that was an incident that happened on the launch pad. They lost they lost the whole, unfortunately they lost the crew in the capsule during that operation.
And the other part is the actual pictures that people claim, the flag and this direction of the sun and all of this like sort of hoax style photography, and I asked this knowing full well, I don't believe in it as being a hoax. I really believe that we got to the moon, but the way you explain why these pictures were taken has something to do with the modern narrative of Blue Origin and Katy Perry and her team coming out of that capsule. People saying that that's like the door, looked fake, and how flimsy it looked. So it all ties in, and you have I hate to say you have an explanation for this, but I mean what you described to me makes so much sense. So can you tell me?
Yeah. So, right. I mean, whenever you do something, especially for the first time, right? Like you don't always want to show everybody the dirty underneath, right? Like it's always you do have to worry about PR. There's public reception, right? How do people see this? You don't want to show yourself as, oh man, we barely did this. Oh, like these people almost died. Like, oh, this was the most terrible, uncomfortable thing, because people don't like to see that, right? They like to see pretty pictures. They like to see, everything through, rose-colored lenses, as they say, right? You want to make it look good, right? Especially if it's going to be on TV. I'm not I wasn't part of the mission that flew, on that New Shepard with Katy Perry and the rest of the crew. However, to the extent that I would say as a person who, and I guess my words are not Blue Origin's words, right? But think about it, right? Like if you're flying a whole bunch of high profile people into space and back, right? There's going to be cameras, right? There's going to be people filming. It's going to be on all sorts of social media, and it's advertising for the company, right? So yes, the mission went, they left, they came back. I know that with fact, right? But I'm sure at some point they were like, "Hey guys, we got to do this one for the photo," right? So how much of that was for, how much of that you actually know of like how the day progressed and how they did the filming for it? It's hard to say because I wasn't there, right? But let's just remember, like, even like think about it, right? With the wedding photo, right? 90% of your wedding photos were taken like 10 times over, right? Like,
Yeah.
cause you want to show the best part of the event. Was the wedding real? Of course it was real, right? You have the documents, you have the ring to prove it, right? But you need to make it look good too. So I think there's a balance of that aspect. And then whenever people find out like, oh my God, that's not the real photo. Like, yeah, well, the real photo is like muddy and it's dark and you can't really see anything, like, you want to have that outside. Now that's just me as a if I were running my own company, that's what I would do. Right? I can't speak to what was actually done. But I was like, hey, hold on, people. Like let's just think about this for a second and not jump to conclusions with these kinds of things.
Yeah, I think it's just human nature too. When we, some of these friends of mine that I have are really into conspiracy, and it's not, it's not the most intelligent, I have to say it's not the most intelligent debates that we have. It's like, it gets exhausting to hear this over and over, flat earth debates and moon landing conspiracy. It just makes no sense to me. And that's why I want to sit and talk to you about the idea of space travel and, what the realities are and what you do all ties into, now expanding our mind, and we're now moving into the future. And I think it's to my good friends who believe in this, all these conspiracies about, Blue Origin not making it into space and the US not making it onto the moon back then. We need to put all that to rest, and we need to really hear what these real life engineers do a real life Vietnamese engineer is doing at Blue Origin. So, so here we are. What is your day to day like?
Yeah, so I work over at the Cape Canaveral, right? It's where all the history was made back in the day in the 60s and 70s. That's where NASA is. It's where Kennedy Space Center is. The Space Force base is over there now. So every day, I commute over there over to the coast. I work right next to a lot of industry. So it's really cool. Actually, driving into work, I can see the visitor center at Kennedy Space Center, and they have the old shuttle tank, and it's sitting outside, and I can see that every day. It's really cool. You can see the VAB way off in the distance, which is like one of the world's largest structures that can hold a rocket inside. So I work over there, but on day-to-day basis, it could be I'm actually down there on the manufacturing floor, working on the rocket. I work a lot on the avionics and electrical parts of the rocket. So it could be I'm doing a test on there. I'm troubleshooting, or maybe someone ran into a problem. The part of the system's not working. So my job is to go down there, figure out why it's not working, give them dispositions, write up engineering instructions on how to fix it, how to correct the problem, or how to just conduct the general tests to make sure that the rocket's working, right? So that's fundamentally my role, if you want to put it simply, is I'm responsible for when they build the rocket, I'm responsible for making sure that specific parts of that rocket, because there's many systems, right? But I have a couple systems I particularly own. I'm responsible that those systems, work. Like, I can put a stamp on it. I say, okay, my name is on this piece of paper that says, Kevin says that this part of the rocket works, right? Like stamped. Okay, good to go, right? But it can be a variety of things. It could be fixing, finding problems, troubleshooting, or just doing routine tests and inspections on as we build the rocket.
And do you ever? This is probably a silly question, but do you ever see things that are defected? Do you ever come across things that are not going to work, and somebody before you passed it along, and it was just?
Of course. I mean, that's the point of the job, right? The point, if people didn't make mistakes, my job would be pointless. Like my function only exists because we have to assume that mistakes were made.
Yeah.
Right. And so we're the integration team. We make sure that it was integrated properly. So of course, we find things. Sometimes I'm like, all right, who's the guy who did this? But that happens every now and then. But that's expected, right? Any complicated manufacturing process, you're always going to have something go wrong, whether it was a design issue or just a defect during manufacturing. Like one day somebody just picked up the wrong thing and used it where it wasn't supposed to be used, and we catch that, right? Or somebody just makes a simple error, like he misread something, and then my job is to go in and test and make sure that any simple mistake like that gets caught, right? We can't allow simple human error to transpire all the way through a manufacturing process, and ultimately my job is to catch all of it. So if I catch something, that means my job I'm doing my job successfully. Right?
Because I'm thinking, when you're doing something this complicated, a million things can go wrong, right? And a million things just takes one thing, like an O-ring for the Challenger to blow up in space. And that's what I'm thinking to myself. How many guys like you exist on your team to troubleshoot, to do quality control before these things get rolled up into space, and you're carrying human beings into the whole idea of Blue Origin is to bring public, regular people up into space, right? So I mean, there's going to be hundreds of these missions in the next decade. I'm assuming, and this is how many of you guys are testing, and how many, I'm trying to wrap my mind around like the process of like getting it all figured out that it's safe enough for us to go into space.
Yeah. I mean, my team's like about 17 people. And that's just one team. We have partner teams that also, do similar roles as us. And that's like 17 engineers. Plus, we have another team that's almost about 30. They're gonna end up around with 30 some odd engineers. And so between all, I don't know, so that's like 40 or 50 some odd people on the floor, working with the rocket, getting through production, getting through manufacturing, and testing for all these things, right? But we're not the final say, right? We're just the people who during the manufacturing process are testing it, right? Once it's done, they go out onto the launch pad and they do their final practice tests and everything too, and that's a whole another team. That's the team where when you think of NASA, you think of the control room, with the big TVs in the front, and you have the people in the back wearing the shirts and the ties, like the classic 90s, or not 90s, classic like 70s flying to the moon, vibe, right? People smoking, I mean, they don't smoke cigars in the control room anymore, but there's a whole other launch ops team, right? That handles that too. And they're a pretty large team too. So it's a pretty big group of people that are responsible for this whole process. It takes many, that's why space industry is not a cheap, it's not right. When you get into this business, it takes a lot of money, right? And that's why you see people, only large companies are really big players in the space right now. But we're seeing smaller and smaller players come up here and there too, but really big barriers to entry because of the complexity, right? And because of how many people need to be involved with this process. Yeah.
How far are we from getting into space travel for the public on a regular sort of? I mean, is this happening already, or just we're only seeing like celebrities go up?
So I guess I would say, by space travel, if space tourism, call it, qualifies as space travel, then I would say, yeah, we're already there, right? I mean, that's what New Shepard does. That's what SpaceX has brought people into space too, right? They don't do it in the same light as what Blue Origin does. But I mean, space travel for ordinary people can happen today. Right now, it's just a matter of, do you have the money to fund it and all that kind of stuff. It's not like jumping on the metro or something like that, right? But one day, right, that's the goal, right? One day the goal is to make it accessible, to make it simply like buying a ticket on a domestic, or I guess in this case more international, or I don't even know what you would call it, right? What do you call a flight that leaves the Earth? It would be just buying a ticket like that and then going to wherever you need to go. So part of it is, we're there today in the sense that we bring small groups of people to space on a almost trivial basis, right? Like we've launched, New Shepard launched, I think they were into their almost 30 flights. SpaceX has brought many crews to the ISS, and they do their own private missions as well. So we're there now to a certain degree. But I don't think we're too far. From the cost perspective, I think we have a ways to go. But from the capability perspective, I think we could do that today. We could bring anybody into space today. It's just how much money, right?
Because cost seems to be around $200,000, $250,000 to get just one orbit into space. I mean, is that the sort of the going rate now?
Oh. Man, I couldn't tell you. That's all the business side of the house, right?
Yeah.
Yeah. It's hard to, for me, I'm more of the technical guy. If I were to try to sell you something like that, I'll get kicked out the door right now. I think you was the worst numbers ever.
Yeah. What is actually the mission of Blue Origin? Because I asked that because I know that SpaceX has its own mission, but Blue Origin, it seems to be a little bit more public passenger. Can you go into the actual mission of Blue Origin? Yeah.
So, I mean, Blue Origin's motto, I guess I should say, it's for the benefit of Earth, right? That's our mission statement, I guess I would say. But what does that mean, right? And again, I'm not a spokesperson for Blue Origin, but I'll tell you what it means as me as an individual, right? What does that mean? And it's really, like we mentioned before, it's enabling people to travel off the earth on a regular, and I would say almost on a trivial kind of basis, right? We want to enable folks who for whatever they need to do, right? Whether that be private industry in space, right? Whether that be going to some commercial space station, whether that be going to the moon for whatever reason, for industry, for science, for tourism, right? To basically enable that, right? Because right now we look at traveling to space as an enormous feat, right? We look at it like how the Wright brothers looked at, doing their first flights. We look at it how when the first domestic airline flights were happening, right? This is like, oh, this is so remarkable. This is novel. This is crazy. Like, oh, do we really trust this, right? Like, think about when cars came versus, horse-drawn carriages. It's like, oh, you can't trust these things. They run on explosions, right? In the machine. I think the mission long term for Blue Origin is to kind of make that transition happen for humanity, right? We want to make it so that it's just the next form of transportation for all the humanity.
When I think about your trajectory and your path, what kind of preparation do you need to do before you get to Blue Origin, right? Like, coming out of school, where did you have to work before you actually got to a big company like Blue Origin? And what kind of things do young people have to think about if they want to go into a company like that?
Yeah. Well, I guess it's not easy, right? I mean, relatively speaking. There's obviously the schooling part of it, right? You got to go through an engineering school, and at that to get into the larger, more well-known, or I guess I'd say reputable or prestigious employers, right? Like, you generally have to have some sort of a rigorous education at some university that's recognized for that aerospace engineering. Now, I'm not saying that you have to do that. Obviously, if you have the ability and you have the talent, I would say personally, it doesn't matter where you went to school, but you have to show that somehow, right? So, there's the academic rigor, right? That's part of it too. It wasn't easy getting through aerospace school. The average GPAs were on the floor, right? Like, your grades were terrible.
Really?
It was very difficult. Yeah. But you make it through, right? You make it through that. So that's step one, right? And then there's how do you get to employment too, right? A lot of people, it's not a unique problem to aerospace engineering. It's probably unique to all college graduates, is how do you land that first job, right? Now, for me, doing things like interning, there's co-op programs and things like that. Those are all things that, if I were talking to a student today, how do you prepare yourself for an industry job, especially in a sector like this? It's, well, you got to get experience, right? You got to get that internship, get that co-op before you even graduate, right? So you got to get experience before you even finish school.
Yeah.
That's part of it, right? And then after I graduated, I had those things, right? I had internships when I was in school. I was working through college. I had real world experience before I got out of school in aviation, right? I had worked with I worked with Gulfstream. They're based in Savannah. They make private business jets, very nice ones. So that's kind of where I picked up the industry experience of what does it mean to work on a modern day aircraft, right? With leading edge technology, with digital controls. How is it all put together? How do they work? How do you test it, right? How does the industry work? And that's kind of where I picked it up. And I was able to transfer that experience at Gulfstream into my first full-time job was actually with a company called Sikorsky. They're owned by Lockheed Martin now, but they make helicopters, right? They make helicopters like the Black Hawk. They're famous for making the Black Hawk helicopter. So I worked for Sikorsky, which is helicopters, for almost 8 years.
Wow.
I worked there. Yeah. I worked there as a flight test engineer. I flew on them, in the back with the pilots. I had my own uniform. I had a helmet, and And, my job there was to basically watch because these were experimental, right? My mom hated this. Like,
Yeah.
what are you doing flying on experimental helicopters? Right? Like, you're crazy. Like, stop doing that, right? But I would fly in the back, and my job was basically to make sure that the helicopter was okay. It was experimental, right? So like a lot of new tech was being vetted out, and it wasn't ready yet, right? So we were there to make sure. We just watched these screens and make sure, hey, this is reading a little high, this is reading a little low. I would tell the pilots, hey, you need to do this because, X happened, so we do Y, right? We were like the human backup computer, basically, because we were still testing the actual computers, right? So it requires some of that. So I did that for quite a while, and I learned a lot about a lot about how modern aviation, modern aerospace, modern aircraft are put together. How do you test them? How do you monitor them? How do you show that they're operating normally, right? Like, you pick up that type of experience lets you pick up on a lot of cues, right? Like, you know what I mean? Like, so when you bring like, and this is very, very key to what makes me or what makes a good engineer in my role, is you have to start learning these cues, right? Like these snap decision cues, right? Because you can't always sit down. Like, you don't have the luxury to sit down, open your textbook, and look at data for days, right? To make a decision. You have to be able to quickly, over time, and this is where experience comes in, right? Like, look at those really important factors. Look at those really important cues, right? And based on your experience, what is this meant for you in the past, right? Okay, when typically, when I see this happen, that's a pattern, right? And these patterns reoccur with these types of systems, right? They're not unique in and of themselves. Like, there are novel issues, but many issues are like, oh, these are common type of issues, and you learn to pick up on those things, and that really improves your ability to make judgment and react and make the correct decision quickly, right? So you're not wasting a week with an aircraft that's not flying, right? You kind of like, oh, okay, I think I got this figured out. You're almost like a detective, right? Like, and the sharper you get and the quicker you can solve these problems, the more effective you become as a test engineer. So a lot of that experience I built up during the 7 to 8 years there. And then I decided to look elsewhere, and then I carried all that experience over to Blue Origin, where I do test engineering now. So applying a lot of the same experience and principles of how do you properly test something, and how can you show something's working or not. That's kind of how the process occurred.
I don't know, but it just sounds to me that helicopters sound a lot more complicated in testing than a rocket. I could be wrong, but a rocket just seems like a tube that needs to go up at the right time and not blow up. But with helicopters, there's just so much going on, it seems like, with the balance, the propellers, and all of that. And did you ever come close to any like bad accidents?
Of course. Yeah. I mean, I was in the back of one. We didn't actually hit anything, right? But we had a near miss, I guess you would say, right? But yes, you're right. Helicopters are complicated, and I think people underestimate the complexity of those machines, right? Just because they seem simple, they're not exciting, right? When you think of like flashy, high tech, cool, you don't think of a helicopter that's just flying around your house that's just making all this noise, right? Like you know what I mean? But yeah, they are very complicated machines. The dynamics involved are very complex. There's a lot of moving parts. The gearbox, transmission, the engine, the controls, the everything, right? So, and then yeah, like rockets, they appear to be simple too. So I would say you're right, and you're right in some of those aspects, right? People say, oh, it's rocket science, so therefore it must be ridiculously hard, right? But in some senses, it's actually not as complex as you would think.
Yeah.
Now there are, that's a very broad and general statement, right? But if you stripped away if you were to just be shown the machine, right, and not understand what it's doing, like if I showed you. If I could show you a design for a rocket and not tell you it's a rocket, or tell you that it was something to go to space with, and I could show you a design for a helicopter, right? And then not tell you that, oh, this is for a helicopter. And you just looked at those two on paper. Yeah, it's very difficult to say which is actually the more complex machine, right? Because you're solving problems that are unique to certain environments that may be more difficult or less difficult, depending on the application, right? Like rockets don't have to deal with like with the whole rotor head system, and that's complex control mechanism with all the dynamics involved there, right? But at the same time, helicopters don't have to deal with the environmental aspects of flying to space, right? So they have their own different problem sets, and I wouldn't say one is necessarily easier or harder, right? But in general, we've mastered. I would say humans have basically mastered the art of making a helicopter, though, right? Like I've seen where we've come from the original helicopters that were they literally look like they're made of sticks, right? To the first commercial helicopters like with Bell and Sikorsky and with the Black Hawk coming around, and we've progressed beyond that, right? Like we're seeing fully digital controlled helicopters. There's no more your traditional you move a stick that moves another stick that moves another stick that moves another, like we're done with that, right? Like we're going full digital. You can make a helicopter that looks like anything, that you can make it fly like anything you want with modern technology and controls, right? So like I would say we've pretty much mastered that degree or mastered that aspect of the industry, and we're just trying to eke out every single little bit of performance or efficiency or automation out of it now. Whereas with rockets, I don't think we're at that level of mastery yet. Like, we're still deriving a lot of new propulsion technologies and things like that to help make that travel to and from space even more efficient, right? Especially like when it comes to reusability and things like that. We're still developing in that aspect, different materials, different controls, different types of just generally different types of technology that will really let us master that, right?
I've flown DJI video drones before, and I, in the early days, a few years ago when I first flew them, I was like thinking to myself, and I wouldn't have brought this up if you didn't bring up the whole helicopter work experience that you have, but I've always wondered why drones were not first implemented in its own form before helicopters. Why did helicopters come before drones? Because drones with the four propellers pointing up and down just seems so much more efficient and much more manageable from a systems point of view than a helicopter. Like the helicopter just seems to have like this vertical and horizontal sort of these things working, and it just seems to be very inefficient and complicated. Why didn't we have the drone mechanism before the helicopter mechanism? It doesn't make any sense to me.
Yeah, that's an interesting question, and it's interesting because it's like in retrospect, right? Like it's one of those things you can only ask in retrospect, right? Once you have the technology, you can look back. It's like, oh, well, this is so obvious. Why didn't we do this before? Right? So I'll answer to the best of my degree, and I'll have to make a few assumptions on things, right, with this type of answer.
And I just want to apologize to the audience how random this question is, but I didn't have this prepared because I just heard your helicopter. When I look at you and when I hung out with you, I always felt like you're some 25-year-old guy, not realizing you're in your mid-30s and you have more experience than I actually thought, because I thought you were just that blue coming out of school. You're a Blue Origin, and that's that's history, right? But no, I didn't know that 8-year at the helicopter company existed. So here we are. We're at this random intersection. I really want to know though.
Yeah. So with the helicopter question and the drone question, so a fundamental difference between drones and I would say conventional like helicopters meant for people and cargo is that drones are electric, right? This is a field that the rotorcraft industry hasn't fully evolved into yet, right? So electric rotorcraft is a different animal than a conventional turbine engine powered with a turbo shaft and gearbox type of engine, right? There's a lot of movement in the direction of electric rotorcraft, meaning the rotors are powered by motors, right? Um, the and then the linkages and everything like that to control the prop or the rotor blades are also kind of electronically controlled. So these have from my experience during my time there, the challenge with electronic with motors and motor with rotor blade control with motors is how much power that they're capable of delivering, how much load that these motors can handle, and how heavy they are. So the problem with today, if you were just want to if you were to take like a Black Hawk, right, I worked on 53Ks, which were humongous, right, like gigantic helicopters. To just put an equivalent electric motor in there, now this is where my limitations of the technology are limited here, and I have to make some assumptions, right? But my interpretation or my understanding of what the problem there was, these motors were not capable of the loads, right? Meaning like it can't handle like a mechanical, like a hydraulic system, right, can handle really high loads, right? Like loads meaning like when you fly through the air, like the air pushing against you, or when you're lifting something really heavy off the ground, like you're picking up a truck, right, with a helicopter. That's really heavy, right? It's really it puts a lot of load on the airframe, a lot of load on the rotor blades, it puts a lot of demand of power in the powertrain system, right? Motors right now, from my time in the industry, motors have a limitation on how much load that they can handle, right? Before you start to backdrive the motor or you overheat them, they get really hot, right? Like so like if you ever go out, I don't know if you ever had like a little toy with a little motor in it, right? Like, if you grab the shaft of the motor, right, and you keep it still and you turn the motor on, and that little shaft can't turn, that motor gets really hot, right? Because that current's not going, that electricity can't go anywhere. It's not turning something, right? And so if you think about it, instead of putting your hand on a little shaft that's stopping it from moving, you've all of a sudden attached that shaft to, some system that's handling a really high load. That motor gets really hot because it just can't handle it, right? Versus in a hydraulic control system, because it's not using a coil of wire to move something, and it's using literally hydraulic force, and hydraulics can be very strong, right? The technology isn't there where for large, heavy lift, high load, high performance type situations, the motor technology is not there yet, and in form factor and because of the loads that they can manage. So like drones is easy because drones don't pick up like tanks, right? Drones don't pick up aircraft. Drones don't pick up giant Connex boxes, right? Like drones don't pick up 20,000 pound loads, right? Drones pick up like an Amazon box, right? They and in how you're seeing them used in modern warfare now, they're dropping like little small ordnance, right? Like, I don't know, maybe 50 pound, 100 pounds. They're not dropping 5,000 pound bombs, right? Like, because they can't lift that, right? So that's where some of the limitations that from my time there, I understand. Well, why didn't we start with quad rotor electronic rotors or propellers? And it's because, well, they don't have the same utility, right? For light recreation, for commercial, for hobbyists who are just carrying a little camera, yeah, fine, but you could totally do that, right? But like you're not gonna be lifting anything heavy. But when we get there though, right? Like when somebody invents the motor, some form of motor, or electronic rotor system that is capable of really high loads, then I think you'll see that shift. But we're not there yet. But the people in the industry are moving in that direction. When I left the company, there were a lot of R&D projects that are shifting towards how do we electrify our helicopters, right? And that's one of the problems, though.
This leads me to the next question, which is propulsion systems. Are we what's more important right now? Propulsion, like the ability to kind of power propulsion, or the rotor systems, things that are like mechanically lifting us? Well, I mean, I think of a rocket and I think of the other side. It's very different technologies between a rocket, the helicopter, and even now when, I know this is going to be sounding wacky. I mean, we get into this territory which drifts into so many wacky things, but alien technology and the idea of propulsion, right? And we can't understand any of it, but the reports come out so often. What is the most important thing that people work on? And I can imagine it being propulsion energy systems, but I'm so confused about like where we can, where humanity is actually going, because it seems like the end goal would be to be able to propel things the way that we see them in these videos of things moving with the speed of our imagination.
Yeah. And that's an interesting one, right? So you have many different like methods of propulsion, right? And we as human beings have been bound to, our minds are bound to, propulsion in the sense of it in an atmosphere, right? Or in fluid, like water, air, right? Like, and then so propulsion in space or on other extraterrestrial bodies like the moon or Mars, right? With atmospheres that are different. Yeah, it's a bit of a paradigm shift, right? Like you can't use a regular jet engine in space. There's no air to move, right? You can't use a helicopter in space. There's no air for the rotor blades to move, right? So with propulsion technology in space is really, it's a movement of mass, right? It's mass. And this is something they teach you in school, right? The only way to move something in space is to take, like conservation of momentum, right? Like if you have two objects, right? The only way to make this one go left is to make this one go right. Like, so they have to go like this, right? So in space, you do that by ejecting mass out the back of the engine nozzle, right? Like fuel, right? Fuel becomes that mass, right? So you're shooting hot air, hot whatever, right? And there's even electron engines now, but that ejection is what's propelling you through space, right? Because there's no air for you to suck. So you carry your own fuel, and that fuel flying out the back of the nozzle at really high speed is what makes you fly through space, right? But on Earth, right, you're moving fluid around, like air is the fluid or water, right? Like you have your physics that go around your prop blade, or you have the physics in a turbojet engine, right? It's moving air that's over here that's not as fast. It's accelerating that air through combustion or whatever other means, and spitting the air out the back super fast, right? So those are like the modern. That's what we're constrained to as far as like propulsion technologies on Earth, right? Now we don't know what we don't know, right? So is there another form of propulsion that kind of shifts that paradigm of using the fundamental of conservation of momentum, right? Of moving mass from here to there to move other objects around. Like, is there another way to create motion without that somehow just puts us on a whole nother level of technology, right? Like, I don't know, like, anti-gravity. Like, what does that even mean, right? Like, I have no idea what that would look like, right? But I'm sure there is a way there. I'm sure there has to be, right? There's got to be another form of propulsive technology that is not constrained to the limitations that we have in engineering today. But it's one of those things where how do you know what that looks like? Because we don't know, right? Like if you went back in time, right, and you told the person who's riding a horse, right? Hey, did you know, if you take this fuel and you compress it and then you light it on fire and you put it through a nozzle that's shaped like this, that you can actually go like 20 times faster than what you're going right now? And they're gonna be like, I have no idea what you're talking about, right? Like because you don't know, right? You're bound by the limitations of what you perceive and you understand of the world around you, right? So how do you invent something that is just totally off the scale, right? I don't know. And I think that's where, when you say how did, like, if UFOs were real, right? That's a whole question on its own, right? And if they move like that, like, what sort of propulsive technologies are they using, right? Like, who knows? And this is where the sci-fi kicks in. This is where we need, like, really creative people who write movies and books to just make something up, and then the engineering follows, right? Like,
Wow.
when with George Lucas and Star Wars, yeah, come on, like, he's just making stuff up, right? Like, but at the same time, like, it's almost counterintuitive, right? And I really like this, actually, personally. Is like, engineering sometimes follows the sci-fi, right? Like, because me, engineer, I'm not creative,
Had
right?
no
Like, I
idea.
can't.
This is so novel to hear this.
Yeah. So, but I think it's really cool, right? Because me as an engineer, like, I'm very rigid. I'm very the way I think in boxes, right? Because everything is defined. Like, everything has a finite solution, finite answer. Like, you know what I mean? Like, it's square, right? But when it comes to, like, creativeness and fiction, that's where people are coming up with ideas that are not bound by conventional understanding, right? So by crossing that layer, it's like, and then you show the engineer, like, the engineer goes and watches Star Wars or watches some other sci-fi films, like, that's really cool, right? It's like, what can we do to make that? Right, because I wouldn't have thought of that. I only think of what I know can exist, right? So, but how do you think of something that doesn't even exist? And then once you think of it, right, then the engineering follows. So I would love to see, people come up with crazy ideas, and then industry, just adopt, just kind of going and really embracing that. Like, how can we creatively really just go into the wild with new technology and new science and things like that, right?
I mean, you think about Star Trek and Star Wars and all of these early sci-fi pictures. Star Trek was having mobile phones, beam down from wherever they were, to the floor of the planet that they were on. It was like the most crazy thing, and I don't even know if they had that technology. DARPA had that technology back then or not yet, but whatever he was drawing on, the creator of Star Trek was spot on. Spot on. And then they probably made the engineering work much, much later.
Yeah.
That all being said, now I wonder why, or to you, I want to hear, why is space travel important to mankind?
Yeah. So that's a really good fundamental question, right? So I think the easy answer to that is, and some people may agree and some people may not, is, Earth is finite, right? There's only so much Earth. There's only so many resources, and there's a lot of constraints of being on Earth, right? That limit the human potential. So I know that's like a very general statement, right? I could mean a lot of different things like that, right? But I think some of the use cases now, like some of the things that are applicable today, of why is space important for people? As I mean, do you like your cell phone? Do you like having Google Maps? Do you like having people who use Starlink now? Like, do you like having internet in the middle of nowhere, anywhere you go, right? Things like that, right? Like, those are technologies that only exist because we are able to put things in space, right? And I think that's just the beginning of it, right? So beyond that, like, we beyond that, like, if we can do this much just by orbiting the Earth, right? I mean, right? And I can't give you the answer because I don't know, right? But think about, well, what other things what other sorts of, like, really creative, really remarkable things could you do by expanding that domain to interplanetary, right? To the moon, to the Mars, to other planets on the solar system, to other solar systems, right? Like, what other things are out there? What other forms of technology could you develop that would revolutionize the way humans operate? And that could be, some new material that's on another planet that we don't get much of here, right? Like, we said, how, like, here we say, oh man, gold is so hard to find, silver is so hard to find, like, manufacturing processes that are really expensive because they rely on really precious metals that only exist in certain places, right? Like, and then this one country who nobody likes or something like that only has them, right? So you can create. I think there's a potential for like you could find abundance elsewhere off of Earth that limit manufacturing. So that could be another avenue too, right? And I know there are technologies or there's research going on and progress in fields that are trying to look at how you can manufacture with regolith, right, which is moon dust, right? It's literally what the moon's surface is made of, right? Like people are actively looking at how can you take this and use it as a raw material for manufacturing, and it's possible, right? There are things that you can do with this, and I know that Blue Origin has a patent on how you can use lunar regolith and develop solar panels, right? So think about that, right? Like if you can manufacture solar panels on the moon, right? There's electricity, there's energy, right? And from there, like the world's your oyster, right? So that could be very real too. So there's a great number of possibilities, but I think just limited to just the examples we see today, like with satellite technology, with communication satellites, with satellite imaging, with GPS. I think there's way more potential if you go beyond just an Earth orbit, right? And I would say most emphasis on industry, most of all, I think.
My God, we can spend hours just talking about the proliferation of different technologies like Velcro and solar panels that are made as a result of the space industry. And how far are we from colonizing not the moon, but like just colonizing another space station or a docking situation in our orbit that we can frequently go to?
So, I mean, we've already seen that with the ISS, right? The International Space Station, and that's been around for quite a while. Now that one's going out of commission at some point, I think. But I mean, that will be replaced with others, right? And that'll be replaced with others using more modern technology. But the ISS is pretty old, actually, if you think about it. Like, I don't know exactly how old it is, but I would say in engineering equivalent, it's probably pretty creaky and pretty old. Now, it's perfectly safe. I don't want to scare anybody about that, but I mean, like, there's a reason why they're talking about decommissioning the ISS, right? It's been up there for quite some time. But I can tell you there's work now that's happening about creating private versions of the International Space Station, right? Like Axiom is a company that's in the U.S. that I think they're doing they're working on things to create a private space station. Blue Origin has a concept for a private space station as well. It's called Blue Reef. So those those are really cool, right? And then I believe, and then China and other countries in the world are also invested in creating international, or not international, but like their own versions of private space stations too. So I think we're going to see more of these. Some will be government, some will be private, some will be international. But that is happening. That is happening now. So if you weren't aware, people are going to build more space stations, and it's not just going to be limited to like NASA or the European Space Industry or Agency. It'll be a variety, right? And that's what the private sector is trying to open up. So you're going to see more for sure. Yeah.
As someone who's directly involved in this industry, if I were to ask you, hey, we got a lot of problems here on Earth. We got a lot of things to solve here on Earth. Why are you trying to solve these things? Why are you taking humanity to space? What's your answer to that?
I'd say you're right. There are a lot of problems on Earth. There's a lot of issues here on Earth that we're not dealing with before we go to space, right? I mean, that's true. You can't deny that, right? I mean, there's war, there's hunger, there's medical, there's disease. I mean, there's many, many, many reasons why you should focus on Earth first, right? I totally get it, right? It doesn't make sense to be playing around in space when you have family members that are sick with some incurable form of cancer, right? Like, why, right? But at the same time, I would say we cannot work in a serial process. Humanity cannot work in a serial process, right? Yes, there are important things that are happening that you could arguably say are more important than developing space technology right now, right? But the thing is, we cannot wait to solve these big obstacles that are facing humanity in line with one another, right? Like we can't wait to solve cancer first before investing in space technology, right? Like we can't wait to develop low cost solutions for housing. We can't wait to develop solutions for affordable and healthy food for the globe, right? Before, like, if you wait for all these things, you're never gonna make progress. And you're gonna be way, by the time you finish whatever this is you're doing over here, you're gonna be way behind over here, right? So I get it that the there are hotter fires, right? There are near priorities that you should address that have high perception, that the public is aware of. But at the same time, like, you can't just totally cut it.
Yeah.
Right. Because otherwise by the time you finish it, whatever you're focusing on first, you're just way too far behind on the other things that you should have also. So it's got to be a parallel thing, right? Like, you have to be able to do more than one thing. Humanity has to be capable of working and evolving in more than one aspect at a time. Like, you just have. If you do it any other way, you're already behind, right? You have to be like that.
Yeah, and this idea of being behind leads me to the next question about something you brought up when we were in New York, is the Lunar Gateway. Because when I think about, behind in what? Like, we're relatively, like, what does that even mean? But now, like, if you take the context of all of the countries participating in, I think it's the Lunar Gateway that can you talk about that?
Yeah. So right now, and this rocket is actually going to be launching soon. So NASA, right? I mean, they're still in the game. So they're about to launch their next really large rocket. It's called Artemis 2. It's part of the Artemis program. And that program, part of that program, is going to be enabling basically a lunar space ecosystem, right? And Blue Origin is involved in this as well. We want to provide launch and space services that enable the transportation from Earth to this lunar ecosystem, right? And to and from the surface of the moon and back, right? So basically, you can imagine a space route, there's the long route, which is like from Earth to the moon, and then there's the short one that gets from Earth just to the Earth orbit, and then the last route, which is from around the moon down to the surface, right? So it's like a 3-leg system. So this system, right, the station that orbits the moon, right, this part of the Artemis thing is I believe they're calling it Gateway, right? And this is basically going to serve as like your halfway point, or your gas station, like your rest stop. I'll just use those words, right? Yeah. So that you hit that first, right, and then from there you go down to the moon, right, and then to go home you do the opposite and come back. So that is in works right now with many different industry providers to facilitate the ease of transportation back and forth from the moon. So that's a really big, and that's like happening now, right? That's like a project, that's a program. There's industry moving in that direction like right now to get those things enabled.
Wow, this is not like some pie in the sky dream, some pipe dream. This is like actually going to happen. This is the way we're going to get to and from the moon in a very systematic 2-3 point rest stop system. Yeah.
So it'll happen. It's just when. The question is just when, and hopefully within before we get too old, right? So, but I think it'll be. I don't have a good timeline on it, but we'll see it within our lifetimes for sure.
So, for you, where do you see yourself? What is like the end goal of somebody like you? Are you thinking about, in 10 years I'm going to be stationed on the moon with my family, and I'm going to be working from that side? We're going to go from the moon to Mars, or we're going to go, like, what's your trajectory in your professional life?
Yeah, so I think there's many facets of that question. There's like, well, do you want to follow the typical career path of any working American? It's like, you work until some age and then you retire, you go to the beach and you drink margarita. Like, there's that answer, right? And then there's the answer of like, oh, your my identity as an engineer never retires, right? Even if I work through, all I can do, at a corporate business, what do I do after that? Like, where does my life end up? I mean, in my vision, I mean, I'm gonna be someone who makes things for the rest of my life. Like, I'm fundamentally an engineer, right? Like, I have to always be consumed with fixing things, making things, or something, right? Like, that's just my identity. Like, I can't imagine a life where I'm just sitting around and I'm not making something, right, or improving upon something. You can't, like, you put me in a room with a bunch of random stuff, I promise you I'll build something out of it, right?
Yeah.
Like, just that's just because that's just who I am, right? So, whether I stay at Blue Origin until I retire or whatever retirement looks like, I don't necessarily know. I guess for me, I do foresee me continuing to stay in some sort of field or industry that is, aerospace related, or at least making something that's leading edge, right? Like, I've always, no matter where I've gone or worked or studied, I mean, what I do is always at the forefront of engineering technology, right? Like, the whole concept of aerospace in engineering and what I studied is like, you're learning about the latest and the greatest of these technologies and engineering associated with the aerospace industry, right? And along my entire career path, I've always been involved with R&D, right? It's all research and development. It's all experimental stuff. It's all brand new stuff. Like, I'm not working on things that we already know exist, right? Like, what I do now, like, I work on the rockets that are like brand new, like, this isn't, and then the add-ons to those that make it even newer, right? It's like, hey, you thought this was new. Now we even have a newer version of this, right? So, like, I'm continuously always working and being placed in sectors that are kind of at that forefront of technology. So I think I'll always be working on something new, something that we haven't developed before, some new form of engineering. And then when I get old, I'll always be doing something, making something, whether it's building rockets in the backyard or whatever. Right? But do I ever see myself like in space as someone who's an engineer? I mean, it's possible. I think it's possible. Eventually down the road, right? Once we start having more and more people in space, once we start having industry in space, you have to have people work there, right? Like, you can't have like, arguably, you could say with the advent of AI, maybe this makes things different, right? But for now, let's assume that AI can't entirely replace us. If you have a manufacturing facility, right, you got to have technicians, right? When things break down, you have to have an engineer figure out what's going on, right? You have to have a site manager, like, you have to have somebody there to understand and facilitate the day-to-day operations, right? It's not going to be, well, I don't think yet it's going to be exclusively on robots and AI, right? But maybe that will happen one day. But I think if we get to that point where we have enough industry in the world or on other planets or in space or something like that, yeah, you're gonna need like an engineer there. You're gonna need some people there to fix things when they break. So I think it's possible. Yeah, like, if I were to work on some new lunar habitation program, and they're building it, and it's 50 years from now, they're building it, and it's like, hey, look, Kevin, you worked on this when they were designing it. You tested it when it was on the ground. Like, we need somebody there on site who knows how to fix it when the system breaks, and we can't send a robot or whatever, right?
Yeah.
It's like, okay, well, someone's got to be there. So I think that's a real possibility of something happening like that. So maybe that could happen.
I got to know you through your wife, who is in the Vietnamese film industry, and what a chance meeting both of you in New York. And I want to end with this with this question about your life trajectory if you don't go to space, or rather, how involved do you think you and Vietnam and the space industry in Vietnam? I mean, how real is a space industry in Vietnam one day, and having somebody like you be a part of their program happening in Vietnam? I mean, I know it's probably a very limited question right now, because probably there's no industry, but I don't know if you know anything about it, if you have your finger on the pulse there.
So I do get like those watch notices, like on Google and stuff. You can you can set up like certain notices. So I did actually see there's Viettel, I think, right? And then there's like the Vin Group, right? And so I know that Vin Group, I read an article, and the people in Vietnam can vouch for this. I don't really know too much about it, but I saw that the CEO, the owner, had actually filed for the name of a new company, Vin Space. Yeah. So I saw that. I'm like, all right. So Vietnam's trying to get in the space game. And it's like, yeah, I mean, it makes sense, right? That's a new hot thing. Everybody's getting into it. I mean, it makes sense, right? Like to be a global or
player.
Yeah, right. You have to start thinking about this, right? Whether that be satellites or launch vehicles or whatnot. And then there's like telecom, right? Satellites, telecom. I mean, that's space too. And I think I've seen things online about, I believe it's Viettel, right? Like the cell phone provider. I think they have satellites. And then that's technically space too, aerospace. Now, not in the sense that we think like Hollywood, right? It's more like cell phones and things like that. But I mean, depending on where he goes with Vin Space, depending on where that goes, I mean, it's possible that they would draw international engineering community to the country. So if they want to keep pursuing that route, then I would highly, encourage that side of that Vietnamese sector to keep pushing for that. There needs to be support from the government too, right?
Of course,
Like there's private, and then there's, because you're talking about flying through the air, and there's also government regulations and support with the industry there. So I don't know, maybe if Vietnam were to create their own version of the space, like a VSA, Vietnam Space Agency or something like that. I mean, those would be the stepping stones that would be something that I would be interested in seeing. But I think one more aspect of that is, and unfortunately, it's with the politics, right? Like, with the history with the U.S. and the government, with the party in control over there, it's a tricky conversation when you're talking about space, because space. We there's the civil side of it, right? And then there's the military side of it, right? Yeah. And it's hard to separate the two, right? Aerospace engineering is innately combined with the military, right? Because we create the latest tech, we create the newest things, and trust me, whenever you make something new, the military is going to want to know about it. Like you know what I mean? Like you can't engineer something, a new technology, and not have the military catch on. So it's always been intertwined, right? Like, and a lot of the things that we work on fall behind a lot of international law and politics with the U.S. Like the U.S. government, there's export control. There's lots of things that restrict the ability to convey information between the countries. Like hell, I even remember like when I was in school, it's like my professor, I think he told me one day, like, you see this textbook? You can't bring this textbook. You can't bring this to China, things like that, because the information in that book would enable you to build military technology, right? Like it's fundamentally the things that I know in my head can be used for good and bad, right? Like we can make things that fly people and expand humanity as a common people. But at the same time, if I really wanted to, the things I know in my head could be used to just kill as many people as you want, right? Like it's a double-edged sword. So that's where the technology and the politics gets a little tricky. Right, so like
murky.
As an American, as a Vietnamese American who lives, have U.S. citizenship and anything like that, working in Vietnam for an aerospace industry or in the space industry, because industry is inexplicably tied to military, space and military is always going to be tied together. That would be very difficult, I think, for any Vietnamese American or any American, anybody really who got their education and works in industry in the U.S. and wants to move that experience to Vietnam. I think there's probably now, I have to maybe talk to a lawyer to confirm all of this, right? But I think that would be an obstacle that would limit how much you could really do, because I could see, especially like if you have a clearance, right? Like if you worked in and I have had to work with people and in sectors where a clearance was required, right? And I can tell you, if you had a clearance or ever were thinking of one, and you go work in the space industry in Vietnam, and you happen to work on a military, rocket in Vietnam, that's going to come up on your, that's going to come up. There's like, oh, who did you work for? Okay, what party is in control over there? Okay, yeah, I don't know. We will want to employ you in the U.S.
Wow.
because you have those connections, right? But that's a real thing. So now, but that's a very unique American problem, right? Because America doesn't like the party in control in Vietnam, right? From a political point of view. So there's going to have to be a lot of development politically, internationally, between U.S. and politicians to how do you enable that international flow of advancement of technology and collaboration in that field, right? How do you enable that? But at the same time, how do you limit the problem of it being tied to like arms and the military, right? So that's always been a challenge. And I know even for the longest time, I think maybe in the last 5 or 10 years, I remember, it was actually pretty interesting news that the U.S. actually for the first time allowed trade of certain restricted items to Vietnam. I think it was engine parts, like Pratt and Whitney engines, I believe, something like that. But they were allowed to like sell them parts, or they allowed Vietnam to actually like make them there for the first time, like, and even that was like, oh wow, hey, they're finally kind of like starting to open the doors a little bit, because making stuff like that over there that is based on U.S. tech, could in some ways you can consider that a violation of the international arms and regulations and things like that. So, is it possible? Yeah. Would I like to see it? Yeah, of course. I mean, working in a brand new environment over there with a different culture, different people would always be exciting. But at the same time, it's like, I think we have a lot of politics that have to be figured out before you can see a fully transparent link of American to Vietnamese aerospace industries, working collaboratively. I think there's a big political block between that.
Yeah. Kevin, this has been quite an enjoyable conversation. This is one of the longest conversations I've had in a long time. Typically they're about an hour, but I could sit here for a lot more. I hope to have you back on, because I think that Blue Origin's probably, having something up their sleeve again, like Amanda Nguyen, Katy Perry, all these wonderful women being put in space and coming back down safely. So I look forward to the next thing that you guys do, and hopefully we can get back on the podcast to talk about that.
Yeah, just look out on the calendar. You're going to see a couple launches soon for our bigger rocket. Hopefully, within the next couple months, you're going to see a couple. So stay tuned, watch the news.
I might have to take my kids out to Florida to come visit you. It sounds like a really interesting place. I sure will. Kevin, thank you so much once again.
Okay. Thank you, Kenneth. It was great talking to you.
Thanks, Kevin.
Thank you for listening to The Vietnamese with Kenneth Nguyen. Special thanks to Brittany Tran, to Jane Nguyen, Catherine Nguyen, Tina Pham, Sydney Jamie, and Christo Trin. Please find us on Instagram, Facebook, and TikTok at The Vietnamese Podcast.